Hello, everyone, and welcome to another episode of Dojo Live this Tuesday, August 16th, 2022. My name is Kim Lantis, airing from my home in Hermosillo, Sonora, Mexico. It's my pleasure to be here. Joining me is America Guerrero.
Hello,
Hey,
I'm
America.
back.
Yes, in Mexico City. And of course, the reason why we're here today, our guest, Carl Dietrich, who is the CEO of Jump Arrow. Thank you, Carl, for joining us.
Thanks so much for having me. This is exciting.
Yeah, it's going to be talk about it. I'm really excited. It's going to be a super fun conversation. I feel like I'm going to be learning a lot today. And you're joining us just north of San Francisco, right? Wine country?
That's right. Yeah.
Right,
We're based up in Petaluma, California. Yeah. But we've got offices on the East Coast as well, and we work with companies all over North America.
All right. Well, thank you. Thank you so much for joining us. We really look forward to learning from you today, future of aviation, really. But before we get to that, let's get to know you, please, a bit more, Carl. Let's talk about your passions, your story, and what's led up to your time with Jump Arrow. Thank you.
Yeah, sure. So I was one of those kids that was fascinated with aviation from the time that I was like 8 years old. Literally, I started saving up for my pilot's license when I was 8 years old, and I wanted to become a pilot because I knew it would make me a better designer of the airplanes that I wanted to build. So like many kids, went off and started building remote controlled airplanes and flying them and crashing them and all that sort of fun stuff. I got my pilot's license in high school and then went on to study aerospace engineering at MIT. I loved MIT, wound up spending way more time out there than I thought. I was there for about 11 years, picking up 3 degrees along the way. And coming out of MIT in 2006, I founded a company called Terrafugia that was building a flying car, a vehicle that could both fly like a small general aviation airplane and drive down the road legally, park in a single car garage. It could convert between flying and driving in less than 30 seconds. And our vision was to try to make personal flight a practical reality for everyone, because we think that this is so cool and so fun and like, boy, it should just be so much more useful than it is today. Right now, it's sort of seen as a rich person's hobby. And I really believed that this was something that, it's the vision of the Jetsons, right? It's the vision of Back to the Future. It's all these things. Those were the things
which came and gone, right? What was it, 2015?
Right.
I don't remember the year.
Right. So
we missed it.
Exactly. So, I mean, I grew up on that stuff, right? And I was like, we can do this. We have the technology to do this. People have been flying airplanes forever. Why can't we just, make them more practical for everyone? And so that was really the vision behind my first company, Terrafugia. And we developed a few generations of prototype aircraft. We actually had the first vehicle to be certified by the FAA as a special light sport aircraft. And it was the first aircraft ever that could convert between flying and driving modes in less than 30 seconds. So we made a number of significant technical achievements and showed that it was possible. The area where we fell short and the area that has held back this sort of thing from being practical for a really long time is that it's too darn expensive. So it was wound up being much more expensive than we anticipated at the beginning of the company to actually produce the aircraft. And so where we thought we were going to bring the product to market and have it be competitive with other aircraft, it wound up being, 3 times as expensive. And that just made it not a great product market fit, even though it was cool, even though it did amazing things. It just wasn't the right fit for the market. It was just too expensive.
So it was 3 times more expensive than other aircraft, not cars.
It was, yeah. I mean, basically, you're talking about a 2-seat aircraft that would have been on the order of $500,000. Okay, and so yes, there are cars that are more expensive, but they're sold maybe a dozen a year. And there are airplanes that are much more expensive, but they're sold in similar volumes. And so you're not going to have a mass market impact, which was the vision of the company, right? Was to try to make this a technology that that would have a big impact, a broad-ranging impact. That sort of vision of the flying car future that everybody's
To the
been
masses.
dreaming about
Yes.
forever, right? So we failed at that, and we knew why we failed at that, because of the cost. And so what we decided to do was kind of take a step back with my new venture, Jump Aero, and say, well, okay, given that today the costs are high, how can we at least take this emerging new advanced air mobility technology, which, by the way, includes a lot of really amazing all electric propulsion technology today that didn't exist 20 years ago, didn't even exist really when we founded my first company. That first product did have a hybrid electric system, but now we can go all electric. So now we can make truly sustainable airborne propulsion. And the vision with this is, let's do something with this where we take the biggest advantages of aviation, namely you go way faster than you can ever go on the ground, and you're not going to be limited by traffic and all this sort of stuff. And let's apply it to the problems in the real world that are the most time sensitive problems. In particular, we're focused on using this form of aviation for first response applications. So for helping getting paramedics or EMTs to the scene of an emergency faster than anything else. And those applications, the value of time is so high that it dwarfs any other use case in terms of the product market fit. So the fact that our early flying car technologies are more expensive than we would like them to be is more acceptable in those situations, because
of course
you can't do it any other way. Literally, we're providing a capability that doesn't exist anywhere else, and we're using it to save lives. So that's really what we're trying to do at Jump Aero.
Yeah, and really that impact, that original vision of to the everyday man, to the masses, flying cars, it's still the same. It still fits in, right? It's just meeting a much different need than we had,
absolutely,
than you had originally visualized.
We still want to go there, right? Like I think my whole life I will want to be pushing hard to get there as quickly as we can. But what we've realized is we need to take a more practical path to getting there, and start with very focused areas where the value of time is just off the charts high. And so if the cost of the underlying technology is higher, it can be afforded for those use cases. Bring it to market there, mature the technology, then you can start ramping up production. Then you can start achieving economies of scale, which we couldn't do coming out the gate at Terrafugia, my last company. So by taking that more stepwise approach, we're able to incrementally reduce our costs over time and eventually achieve that vision of the Jetsons, but in a more practical way, I guess.
Yeah, which actually is, a great introduction. I think you answered a large part of the topic and the tagline that you chose today, America, which is?
The next aviation revolution. How can we achieve the vision of the flying car in a practical way? So you already told us a little bit about the how. So why did you choose this topic?
Well, flying has been around since 1903 with the Wright brothers, right? People have been flying little airplanes, and we achieved some, what I would call broad-based public use of that in commercial airlines. But those flights are all like big flights, transcontinental flights. You're packed onto a flying bus. You don't have the freedom that you have in your car, to go wherever you want to go, whenever you want to leave. And there is a segment of the population that has that freedom today, private pilots, but it takes quite a bit of time and money and experience to become a private pilot. There are some pretty high barriers. And what we really want to do, what I would really like to do, is help lower that barrier to entry so that we can make personal flight more practical for everyone, more useful. And that was the original founding vision of Terrafugia. And in some ways, it is a guiding force behind Jump Aero. What our mission really is at Jump Aero is to use this technology to help save lives. because that's the area where today the technology can have the biggest impact.
Of course. So at Jump Arrow, where are you today? Like, are you at what stage of this vision? Do you have working units? Are you deployed in cities around the world? Is it still in the design phase? Like, what's today look like, and how do you see that rolling out over the next few years?
Yeah, so today Jump Arrow is not yet deployed or anything like that. We're in the developmental stage. We've been flying what we call subscale demonstrators because the aircraft is basically flown by a computer, with pilot guidance, but it's effectively a computer-controlled aircraft. So the technology behind it has been matured by many companies over the past 20 years. Fly-by-wire flight technology has been around for quite a bit longer than that, actually. But it's just starting to make its way into the small end of aviation. So in other words, military aircraft, very high-end, very expensive fighters have had this stuff for a long time, but it's never propagated to the personal aircraft that individuals can use and operate and buy, or even flight departments for a hospital or something like that. That's been sort of out of reach because it's more expensive, or it has been until fairly recently. And now with, of course, the miniaturization of electronics and the advent of more advanced software and flight control schemes, and the evolution of a regulatory environment inside the FAA and EASA in Europe, and regulators around the world are adapting their regulations to this new technology and providing a path to certify the technology to get it out to market. So that's really the revolution that's been happening over the past decade or so, is that the regulation and the technology have come together and kind of made it possible for us to bring all electric vertical takeoff and landing, what are many people call electric VTOL aircraft, eVTOLs, vertical takeoff and landing aircraft, to market. And over the past 5 years or so, about $15 billion has been invested in this space by companies all around the world, including almost all the major aerospace OEMs. And many of the automotive companies have thrown their hat into the ring as well. So this is a huge area. I mean, we are likely to see a major revolution in the small end of aviation over the coming decades. Very exciting. It's going to come to market in a couple different ways. One is small air taxis, where you might share a ride with a few other people and get an electric aircraft flight to the airport to take your big flight, that sort of thing. And then there are other applications like what we're doing at Jump Arrow, where we're focused on helping first responders just get to the scene of an emergency faster than they can today.
Right. So your vision is in the sense of a flying ambulance. It would be get there, stabilize things, but the transportation of the, what are we calling them, victims or person in need, patient, thank you, would still be moved in a more traditional fashion?
That's correct. Yeah. And the reason is that there are actually aircraft that are really good at transporting patients right now. They're helicopter air ambulances. Are the new piece of technology is really the all-electric part of it and the fly-by-wire aircraft part of it. So those are the two key pieces. And the thing that those two pieces of technology can really help you do is deploy much faster. So you can get to the scene faster. And the reason that you can do that is that fundamentally, one of the big advantages of an all-electric aircraft is that you can basically just switch it on and go. You don't have to wait for an engine to warm up. So a helicopter air ambulance that runs on a traditional internal combustion or turbine engine, you can't just go to full power instantly, or you can, but you actually wind up wearing your engine down faster when you do that, because the whole thing is a thermal engine. It has to heat up. And if you heat up the inside faster than the outside heats up, it'll cause problems to the engine. So this is just a fundamental reality of any sort of hydrocarbon combusting.
I had no idea.
So, and this is one of the things that I think we've been somewhat unique and recognized. Lots of people recognize that all electric is green, and that's awesome. And I love the fact that we're making a sustainable form of aviation transportation. But what we also recognized was that there are things that all electric aircraft can do that literally you can't do in a normal aircraft. Specifically, start up faster, start up instantly, go instantly to full power, and then shut down instantly. You shouldn't do that in a normal aircraft because you have to heat up your whole engine block. You have to, and then turbine helicopters, you have to let the turbine cool down. It takes 2 minutes to shut down a helicopter. It takes 3 to 5 minutes to spool one up, right? What we're looking to do is make a difference in those first few critical minutes when somebody has, for instance, an out of hospital cardiac arrest, right? There are 350,000.
7 minutes is an eternity.
It's huge.
It's the difference between life and death, or even if you're in the life frame, life worth living, or a vegetative state. Like,
that's it. Exactly. No, the timeline is incredibly bleak, right? Like if you have an out of hospital cardiac arrest, you lose oxygen flow to your brain, you're on the clock from that point on, right? So then hopefully somebody recognizes and calls 911, or emergency response gets initiated then. But at that point, the clock starts ticking. And if it takes you longer than 15 minutes to get there, basically you're dead. There's no way to come back. If your brain hasn't had oxygen for 15 minutes, you're gone. The average first response time in the rural United States, so first world country, like this is not like middle of nowhere. Rural America today is 14 and a half minutes. So basically, if you have an out-of-hospital cardiac arrest in the rural United States today, unless somebody is right there who's trained in how to do CPR, you're dead. That's it. And what we can do with this technology is we can change that. We can cut that 14 and a half minute response time in half and get it down so the average response time in rural areas is like 7 minutes, which is basically what it is in urban settings. It's usually like 7 to 8 minutes. So it is literally the difference between life and death, or at least like brain damage and no brain damage, right? It makes a big difference, and it has a huge impact on long-term care costs. So the health insurance companies should care about this. There are lots of sort of ripple effects that come out from like focusing on what can we really do with this new technology? What can have the biggest impact?
I'm imagining that scenario. So how high that car, the flying car, is going to be? How high? Because I'm imagining that in the traffic, here are the cars, and then this new car flying device will go like this, like just over the cars, or there are not going to be limitations?
No, they're going quite a bit up higher. So for instance. So for our deployments at Jump Arrow, we're talking about actually having these aircraft. They could be based at a hospital. They could be based at a fire station. They could be based at an airport, a little general aviation airport. And when the call comes in, the people have to get it up in the air. We're targeting less than 1 minute to get up in the air. And then they're taking off and they're flying at an altitude between 500 feet and 2,500 feet, depending upon the terrain. Depending upon obstacles in the area. So they're quite a bit higher than any traffic on the ground. They're not flying like right over the tops. This is more like, if you think of little airplanes like Cessna or Piper aircraft, tiny general aviation airplanes, they're sort of flying at those altitudes. So they're not flying as high as the big commercial airliners, but they're flying quite a bit higher than than things that would be right above the highway, and they're not flying
to avoid obstructions and to impact that speed, right? If you're zooming between buildings, A, that's not fast as it could be, and B, it's potentially dangerous, right?
Exactly. And there are already regulations that cover all of this, right? So we're not creating any new rules on how to operate aircraft. These rules have been out there for a long time, and there's no need to change them. They're well based. They're founded in the need for safety. And so we abide by those rules. It's the thing that we're doing is just bringing this new piece of technology that helps you go faster, basically get to where you're going much faster than you could do with any previous form of aviation.
So with your vehicles, let's talk a bit about the hardware software side. You already mentioned that the majority of it is a computer. I imagine it's maybe a two-person vehicle. One is the pilot, one is an EMT, or what that looks like. But in terms of the vehicle itself or the technology, what is more important here? Is it the mechanical side, the hardware side? Is it the software side? Equally important. What's that breakdown kind of look like?
Yeah, it's you have to have both, right? And you have to have outstanding control over the design, the requirements, and eventually the production and the chain all the way from the raw materials that make the components all the way down to the finished product and the final acceptance testing of the product before it's deployed in the field. So it is an aerospace product. Lives are on the line. It's safety critical. It absolutely has to be built to the highest standards. So you can't really say that the software is more important than the hardware, or the hardware is more important than the software. It all has to work together the way that it's supposed to, and it all has to have been designed to meet the necessary requirements, both for the utility, the use case, and the regulatory requirements for certification that are driven by safety. So that it really all comes down to safety, and how do we ensure the highest level of safety in this new form of transportation.
And do you think they'll equally keep evolving? Or will the mechanical side eventually, let's say, peak? This is as good as we can physically make something, but the software side can keep going? Or is there going to be a continuous evolution on both ends?
Well, as I would say, the pace of development of materials, which are really the driver for mechanical performance, tends to be slower. We had some major revolutions happen and going from in aerospace, going from wood and fabric construction to metal construction, aluminum construction aircraft, which still many aircraft are made with all aluminum construction today, to carbon fiber construction, which our vehicle will utilize quite a bit of carbon fiber. But there are new materials and additives that can enhance the performance of even carbon fiber layups today and make them even more strong or more resilient to damage or that sort of thing. I think we'll continue to see advancements in those areas. On the software side, obviously, there's quite a bit of change can happen much faster, which is actually a challenge for a safety critical application because and this is one of the areas where there's a very different mindset in Silicon Valley than there is in the FAA, for instance, because Silicon Valley, it's all about make it, break it fast. Just
fast,
iterate
yeah.
as fast as possible. Failure is good. Just keep churning, right? Well, if you've got software that's flying an aircraft, you can't take that approach, right? We can't afford crashes. We can't afford to break it all the time, right? So
yeah, literally and figuratively.
Yeah, so you have to adopt a different developmental approach where in certain stages of development, you want that fast churn. Like when you're doing what we're doing now is we're doing a lot of flying in simulated environments, right? So we're doing that fast churn and that iterative. I mean, in simulation, we've crashed things, I don't know, thousands and thousands of times, right? But that's part of the iterative development of the requirement basis for what the software needs to do. And then once you figure out what the software needs to do, you lock it in and you don't change it. And that's something that Silicon Valley doesn't know how to do well, frankly. They do a lousy job at that. So but you have to do it to go into hardware that's going to fly. And the process of iterating that is a big deal. And it should be, frankly, because it's safety critical. If you have a bug in that code and that code is now flying your airplane, that's a big problem, right? It's a safety issue. It's not just that my website isn't loading fast or something like that. It's a safety. So it really does require a different mindset in the different phases of development. And that's one of the challenges that many of the companies in the space are having to cope with right now, is that you have almost completely different mindsets that you have to organize under one organization and get to work. So you take advantage of the goodness of both.
Yeah.
They both have
And
a
I think that
place.
actually that brings to a really good point. Usually on our show, the final few minutes, we like to turn it back to kind of company culture and, you as the CEO, like what it is that you're building, the people that you work for or with rather, mindset. That too, right? But talking about that mindset, how do you build that culture, or maybe even have you had to sort of unteach certain things with the individuals that you're working with because of this, traditional fast-paced, like how do you work that into the culture that you're building? What's the culture like?
Yeah, that's
at
one of the
Jump
biggest
Arrow?
challenges of doing stuff in this new field, is that you want to have um, a little bit of a mix, and to a certain extent it's very hard to do that. So one way of doing it is to leverage outside groups for what they're good at. So if they're outside companies, for instance, we work with a company that's in Mexico that is very good at safety critical software. So there's a particular process that you use to develop safety critical software. They do it all the time for big aerospace companies. They know how to do it. That this is their bread and butter. That's what they do. That's baked into their culture. It's baked into their internal processes. I wouldn't want to try to take a Silicon Valley startup company mindset and ask them to do that process, because frankly, they'll fail at it. We use a company like that that's good at it, and we use them as an outside contractor. So there are certain aspects of owning the requirements that Jump Arrow must own, right? We have to know what the requirements are, what the requirements need to be, because that's the definition of the product. So we have the people that will figure out what those are. And then we'll work with outside companies that may have a different specialty, a different focus, and in some ways even a different culture, that are just really good at doing what they do. And that way I don't have to build that different cultural institution inside my organization, right? This is one of the reasons why, in major OEMs use suppliers, is that you can break things up more efficiently that way, and you don't have to deal with as many internal cultural challenges. You can have a very unified team, and we can say what we need to do. What we need to do very clearly is we need to own the requirements. We need to develop those requirements. We need to mature them. We need to have confidence in them. We need to know why we require this, that, and the other thing, right? We need to be able to explain that to anyone. And then
And it's really smart.
taking
Go ahead.
the benefits of other companies and what they're really good at, we can put together a product that leverages those diverse expertise. So that's the way that we try to do that at Jump Arrow. Is we don't try to
It's
mush
really
them all
smart.
together. It's very
It's a
different.
super smart approach. I mean, I always hear a lot of CEOs on the show mention how when it comes to building their team or their individuals, they're able, a good CEO is aware of what he or she doesn't know. And then they find people who do know that, I don't have to know everything. I don't have to be the best at everything. I need to find the people who are the best. And I think it's just that same concept, but blown up, right? In terms of suppliers and people that you choose to partner with. Carl, what's your process that you utilize to choose who you're going to work with in those terms? Do you have, what's your approach in making sure that you're partnering with the correct companies?
Well, so in an industry like aerospace, if you're doing safety critical work, there are well-known companies in the field that have been around for a long time, that already have those internal processes baked into their organization. So, like I said, what we do is we try to leverage that to the extent possible. For hiring into our company, I do look for folks that have some exposure to the requirements mindset, right? And that doesn't have to be folks that are coming out of aerospace, although aerospace is very much a requirements-driven field. Automotive is also But in general, we tend to shoot for folks that have a little bit more of that sort of physical production mindset, requirements-driven processes, as opposed to what I would call the Silicon Valley, make it, break it fast. But we ask our guys to exercise their make it, break it fast as they're figuring out what the requirements should be. But they have to know how to zero in on and then put a stake in the ground, right? Because that's one of the things that's very different about developing a product for this market compared to developing a product that's a piece of software that's going to go out just on the web or something like that. You can continue to iterate that as fast as you want, as come out with a new feature every day, blah, 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 blah. That's fine. No problem. Nobody's going to die if it doesn't work. Our products, that's not the case, right? We have to have a very rigorous process from the point where we talk about, okay, we're putting a stake in the sand saying these are the requirements. From that point on, it's a very rigorous process, right? Until you get there, you can play around a whole lot. You can do all sorts of crazy things, right? But I need a team that's going to recognize the importance of getting to that point and defining that point very clearly, right? So that's what I look for folks inside Jump Arrow. And, it's not so critical what their particular background is. It obviously, it shortcuts interview steps if I know that they've worked on other certification projects and stuff like that. But you don't have to, it's more of a mindset thing. It's like, you have to stop changing the requirements at some point, and lock it in and then move forward. And that's just a different tack. So if there are people who like that idea of getting to a finish line and stopping and then putting it into a different phase, those are people that I would be interested in talking to. But you gotta be willing to stop.
Yeah, and it makes a lot of sense, and I think there's a good fit for a lot of different people out there. It's been a wonderful show. Thank you so much for bringing us into the world of aviation, Carl. Here, it's fascinating. It's fun. I think it's definitely something that's going to draw a lot of attention for a lot of people who want to be involved in what the future is going to bring. So, congratulations! I applaud you for your visionary. Just the way you are a visionary, even since childhood. It's absolutely fantastic. Thank you.
Thanks so much for having me on. This was fun.
Yes. And we'll in a couple years, we'll bring you back and hopefully we can have a demo.
Cool.
All right. So hang on just a second as we go off air. We do have 2 more shows coming up this week, also at 12 o'clock Pacific. Who will we be talking to, America?
Tomorrow, we're going to talk with Ross Bordroff, CEO at SEM Business, and the topic is entrepreneurial optimism in a turbulent economy. So, the resurgence of the American entrepreneur. More and more people are leaving their jobs despite their turbulent economy for something better, being their own boss. That conversation, we're going to have it tomorrow at 12 p.m. Pacific. And then on Thursday, we're going to have another show with Travis Rush. He is the CEO and co-founder at Reperior. And the topic is bringing healthcare into the home. 12 p.m. Pacific.
Right, perfect. Mm-hmm. Don't miss it. Stay safe. And thank you all once again. Bye for now.